Good morning. Turn to page 483, absolute value inequalities. Some of you all have been making mistakes with absolute value, not realizing that if an absolute value is less than something else, it's a graph that's going to come together. If it's an absolute value that's greater than a number, then it's going to go away from each other. Remember, the ones that come together are conjunctions, and the ones that go apart are disjunctions. The word "and" indicates a conjunction where they come together, like this. And the word "or" indicates a disjunction where the graphs go apart in some way. All right. So on page 483, the first example that we have, it's in set builder notation that we learned yesterday. X is an element of reals, which means it's a real number. It's not on a coordinate system because it doesn't have an r squared. Absolute value of x minus 2 is less than 4. Now this is different from the ones that we had in the past because the ones that we've had in the past were something that had just an absolute value of x, not an absolute value of x with a quantity. So these are going to be treated differently. The symbol less than indicates it's a conjunction and it's going to come together. The symbol greater than indicates that it's a disjunction and it's going to go apart. So when it is a conjunction, which this one is, to solve it, all I need to do is bring the x minus 2 less than 4 without the absolute value down. And I take this symbol right here and I put it in front. And because when I take the absolute value of a number and I tell you that it's 7, the number could have been positive 7, or it also could have been negative 7. So here we have a 4. It could be 4, or it could be negative 4. Okay? And now once you have this set up, we want x by itself, so we have to add 2, but remember we have 3 parts here. So we have to add 2 all the way across to each part. So this will be x is greater than negative 2 is less than 6. And then we go back up and remember that our domain is reals, so it's okay to have open, closed dots and arrows. So let's see if I have... All right, greater than negative 2. Is negative 2 included? No, so with reals we put an open dot. And the same thing, less than 6. 6 is not included. All right, so numbers greater than negative 2 are going this way, and numbers less than 6 are coming this way. So we just draw the line to where they meet. That's a conjunction where they come together. All right, another one similar to that on page 484. And also in set builder notation, but this one says x is an element of z. What was z? Okay, z is integers. So all we can have on the graph are a bunch of dots. No open dots, solid dots only, and arrows, or just the dots that come together. And because this is a less than or equal to, we know it's a conjunction, so it is coming together. Because it's coming together, it's all right if we write it together. So this would be x plus 2 less than or equal to 3. In other words, copy this down exactly the same without the absolute value. Take this symbol, copy it down in front. Okay, we have the positive 3 here, so what do we put on this end? Right, negative 3. Now solve it for x. So minus 2, minus 2, minus 2. So x will be greater than or equal to negative 5, but less than or equal to positive 1. Okay, so this one will look different because it only can have solid dots on it. Okay, this says x is greater than or equal to -5, so is -5 included? Yes, so we start on -5 and numbers greater than that are coming this direction. And then over here, less than or equal to 1, less than or equal to, so 1 is included. Keep coming back, less than 1, until we run into each other. So that is the solution, from -5 to +1, only integers. All right, those were both conjunctions. The next one is going to be a disjunction, and I know that because of this symbol right here, greater than 3. This has a domain of real, so we're good to have open or closed dots and arrows. We're good. And you notice this one is not in set builder notation. It's the old notation. So you need to be comfortable working with both notations, the old one and set builder notation. All right, so here, because this is not a conjunction, I cannot write them together. So I have to say x minus 2 is greater than 3, or then I copy it down the same. X minus 2, I put this symbol in front and I change that to a -3. I just cannot write them together because they're not coming together. It's not a conjunction. We're going to solve it the same way. So this will be x is greater than 5, or x is less than -1. And if you need to see that in the other direction, you could write it as x less than -1 or x greater than 5. It doesn't matter. If you're fine with that, that's fine. You always read from the variable out. So this is x less than -1. Okay, domain is real, so we don't have to worry about just a bunch of dots. I've got... all right, so what kind of dot do I put on 5? It says greater than 5. So I put an open dot. Which numbers are greater than 5? That's right, to the right. And then what kind of a number do I put on this? And when it says less than, only less than, so it's an open dot. And which numbers are less than -1? That's right, going to the left. So you see this is a disjunction. When it's a greater than symbol, it's going to go away from each other. That's a little check that you can use after you finish working your problem. Okay, one more for today. Bottom of page 484, it says graph. X is an element of z, so we got integers going on again. X plus 2. Greater than 4, so that is a what? Conjunction or disjunction? It's a disjunction, which means I'm going to use the word or. I cannot write them together. So I'm going to just copy this one down right here. X plus 2 greater than 4. And over here I'm going to put the x plus 2, but remember I take this symbol, put it in front, change that to a negative and put that in front. And now solve each one of those for x. All right, so on the number line, this time I have to have 3 dots to indicate a pattern in each direction. So okay, so do I put a dot on -6 and +2? It says x is less than -6, x is greater than 2, and our domain is integers. So do I put a dot on -6 and 2? No, I don't put a dot of any kind. I don't have open dots with integers, so I skip here to the next number less than -6, which would be -7. And then the numbers that are going to be less than that will be to the left. And how many dots do I need to put on this graph to indicate a pattern? 3, that's right. So now I can draw the arrow. Then I move to the other side. Greater than 2. I don't put any kind of a dot on 2. I skip to the next greater integer, which is 3. So 3, 4, 5, and then I draw the arrow to indicate it's going to continue to do that. Integers only in both directions. All right, guys. That's it for today. I'll see